If you could all promise not to hate me on Thursday, that would be great. Everybody promise? Okay, no, we're gonna hate you. Okay, that's fine. I'll take your hate. I'm a math teacher. I'm used to it. All right. So I came up with a fun scenario. It's not really fun, it's about the tree. But anyway, I came up with an interesting scenario. This scenario is actually from the old pre-calculus hardcover book that we used to use. Anyway, okay, so a park ranger is studying a disease that's found in trees in a forest notices that 16% of the trees seem to be infected, and there does not seem to be a pattern to the infection. He wants to investigate a sample of 30 trees, find the probability that exactly 5 trees out of the 30 are infected. Discuss how labor intensive this would be with your current knowledge. Okay, so this is a probability question that would require a gigantic tree diagram, which would be about trees, which would be fun. Okay, so the first branch it would be disease, not diseased, right? 16%, 84%, 16, and then you go, okay, next trees would be 2 branches off of that. Yes, no, 4 branches off of that. Yes, no, yes, no. That would be the third one. And the tree diagram would go out to 30 trees. It would be extremely large. Now, this particular student here has a really comfortable grasp of combinatorics. Combinatorics are combinations and permutations. Okay, and we learned that in math 2 a little bit. Do you guys remember the C, like 5C3, 5P3? Oh, yeah, okay, that's what this is. Anyway, okay. So fun fact is you're supposed to come into this class with a knowledge of what a combination and a permutation are, and it's supposed to be pre-calc standard. So when I say pre-calc over here, it's going to be something that you're supposed to learn in pre-calc, but then talking with my beloved best friend pre-calc teacher, and he just skipped that track. So I'm going to teach it to you from scratch because you need it. Okay, anyway. What I'm going to teach you today is how to answer this question without making a gigantic tree diagram that would take up my entire whiteboard. Okay. Binomial distribution. Okay, so binomial is something that you learned about all the way through math 1, math 2, math 3. A binomial is something plus something or something minus something. So x plus x or x minus x. Remember when you multiplied binomials, you use the box. So like 2 binomials would be a 2 by 2 box. Okay, and in stats, it means something very specific. It's got its own distribution. It has its own graph, its own shape, stuff like that. Okay, anyway, for something to be binomial, for us, it has to meet 4 requirements, which I've included up here. So I want to know if you guys can guess any of the 4 requirements for something to be binomial just by reading this. Okay, I'm going to take that and say fixed number of trials. Okay, in this case, in this particular problem, that is n equals 30. Fixed number of trials means you're trying it 30 times.
Oh, and like I'm gonna do a 5. I don't know what it is. Is one of them like part of using the frequency?
No,
Blind by them.
it's more just read what's here. It's just like you're trying to make it more complicated than it is. It's oh, Ryan, yeah, sorry. Right. Okay, so that's called independent. So each child is independent. Each tree does not seem to be infected and no pattern to the infections. Okay, and so we're gonna say it's not the fact that it's random. Um, there's two more. You have not used everything in this. Okay, so the next one is you seem to have the same probability for each child, meaning that each tree is 16%. It's not that this tree is 16, and then I come over here and this one's 30, and I go over there and that one's a lot something. And I'm doing two things here. I'm listing the requirements, but I'm also rewriting this stuff in like probability lingo. And then the last thing you might not think about, it's success or failure. It's a success or failure type situation, which is infected or not infected. I have to tell you that in stats, a lot of times the word success goes with something bad. In this case, a success would be finding an infected tree, which doesn't sound like something that's very successful, but that would be like a yes response. Think of a success as a yes and not a no. Okay, anyway, there's your 4 requirements for something to be binomial, which is really good news. That means I get to use special stuff and I don't have to use a tree diagram about trees. Okay, now we're going to calculate. I'm going to show you how we would calculate this in pre-calc. And to be honest with you, there are problems in the MCQs that look like this. So you're going to need to know it, even though it says pre-calc. Okay, anyway, you would say, what's the probability that X equals 5 trees? So it says find the probability that exactly 5 trees of the 30 are infected. Okay. All right, and then you would write this. This is notation you've never seen before in your life unless you just happen to be repeating this class. Oh, okay. So what does this mean? This is stats notation for 30 combination 5. 30 choose 5. Yeah, so it means how many groups of 5 can I make out of 30 objects? It's going to be a large number. Okay, luckily we have calculator. Okay, now thinking about the tree diagram, this is really important. The 30C5 would give us, please listen, this is hard. Would give us how many branches at the end of that tree would have exactly 5 infected trees. Okay, so this tree is yes, no. Okay. Yes, no, yes, no. Can you picture it? Yes, no, yes, no, yes, no, yes, no. Okay, follow that all the way out to 30 trees. Draw the line and then count how many of them are yeses. 30 combination 5 will give you how many of the branches would have exactly 5 yeses and all the rest of them would be no. Yeah.
Each tree you're voting that.
Yeah. This is exactly what you did when you counted the number of options for the essay. Yes, 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 no, yes, yes, no, no. This is the same thing as the list of things for the like tree diagram challenge we did. Okay, now we have to now talk about what we would do to multiply down the branches. So there's this many branches. And 5 of them would be yeses, infected. And 25 of them would not be infected. Okay, so thinking about that tree diagram, you guys remember starting here, it would be 0.16, 0.84, right? 0.16, 0.84, 0.16, 0.84. I have followed that all the way out to 30 trees. This would give me how many branches had 5.16? And it would multiply down the branch. How many branches? And then each branch would have 5 yeses and 25 no's. Do you guys all see where the 0.84 came from?
Yeah.
Do you see where the 5 and 25 came from? Are you sure? You do see it. Okay, all right, so now let's type it in the calculator. So, and we get to type it in one swoop, great. Okay, so if you guys were messing around with rand_int, you probably found the permutation and combination stuff. It's in the math probability, same spot where we do the rand_int, no repeat. You want the third one. Mm-mm. Mm-mm. Okay, any questions about this? Anyone need any calculator helpsies? Yes. Oh, yes. Close your parentheses after 30 combination 5 and then put. Oh, does that work? Did it work? Okay, wait, hold on, I got you. Wait, we're toast. Get that 31 first, then, and then go times 0.1. Okay, all right. Now, statisticians, us in our class, we're too lazy to do this, although College Board asks you for it, so I don't know what to say about that. But we actually have special buttons in our calculator just for this situation. So we're gonna say instead probability x equals 5. And then we're gonna say this is binomial, so binom PDF, kind of like normal CDF, PDF. Yep. And then you're going to write 30, 0.165. Okay, let's do this together and let's see what it wants. Okay, so Binomial PDF is located in the same spot as normal CDF. So go second bars. And then I'm really lazy. I scroll up instead of down. You can scroll down or scroll up. Second bars. Second bars. You can scroll down if you want to, but I'm too lazy. I scroll up because it's faster. Okay. And then look at the menu. It's asking for, oh goodness, what was I doing? Okay. So it's asking for number of trials, which is 30 trials in this problem. Probability is 16% per tree. And the X value that we're interested in is 5. Okay. And these are labeled N, P, and X. Okay, now if you have an older calculator, just type it like this. Be totally fine, I promise.
Wait.
Yeah, okay. Okay, what I just showed you was two different methods to calculate the same thing. That's the pre-calc method, which is supposed to be pre-calc. That is the stats method. Now, when I say pre-calc though, I looked at the College Board MCQs and there was one that looked like that. So I guess it's just math and stats. But anyway, okay, so I don't care which one of these you use. Usually everyone in my class uses the binomial because it's easier than figuring out all that other stuff. But you can do whatever you want. Okay, now I want you to, in your groups, do the probability that 150 trees are infected out of 1,000. So figure it out, what changes, what stays the same. Okay, and then while you're working on that, I'm gonna bring you a chemistry test. One per group. You can work on it with your group when you're done with your other problems.
Wait. I think this is that, but- Yeah.
Okay. Probability X equals 150. Binom PDF 1,000 0.16 150 and X equals 0.024. That is a full credit answer showing all the work. And that answer is also full credit for College Board. Because you got your labeling, you've identified binomial, and you have your answer. How did we do? Everybody got it? It's not too bad. Okay. Now, take a look at this chemistry test I've given you. Where's my chemists in the room? What's your status on snutonium? How do you feel about fluttles? Okay. Think about the chemistry. Please stop. Think about the chemistry test quiz while you're writing the note. It's I've been saying it wrong for years. Gadflights? Oh. I stole this guy from CPM. You'll notice the thing that says resource page on it, but I thought it was still really helpful. Okay, so look back at your requirements for a binomial distribution. We're going to see if this scenario is binomial. It better be, because that's what this whole section's about. But anyway, okay. So my first one was fixed number of trials. Does this particular situation have a fixed number of trials? Yeah, so n equals 4. There's 4 questions to answer. Each one of them is a trial. Okay, what's the next one? Are they independent of each other? Meaning, especially if you don't know any of the material. That says independent. I don't know what happened with my pen. Yeah, okay. Same probability for each one. What is that probability? Yep. 1 out of 5 or 0.2. Sorry, I keep messing up. It's because Jamie's completely distracting me. It's true, though. I meant to put a check mark here, and I got so distracted, I didn't even. Okay. All right. So what this means is, because we satisfied all 4 of these things, we get to use Binom PDF on the calculator to create our valid probability model. So this is going to be all of our outcomes. And so this is there's a possibility you could get 0 correct. or 1 correct, or 2 correct, or 3 correct, 4 correct, which is probably not really likely considering we know none of it, right? And then these are going to be the probabilities. So I want you guys to go back into your Binomial PDF. Okay, and you're going to go trials are 4, probabilities 0.2, and the first one we're going to do is 0, and then that's 0.4096. Okay, now let me show you a trick. You can scroll up in your calculator and then hit enter, and then just go change that to a 1. And this is the same answer twice. That's not a typo or anything. Anybody remember where in Math 3 we actually study this? It has to do with tangled. Uh-huh. My little guy over there. Over here, the squishmallow, what's his name? Pascal. What'd you study in Math 3? Pascal's triangle, yeah. Nice. Okay. All right, now for make yourself a little note that you got those doing fine on PDF. PDF does not stand for like whatever digital format. It's probability density function. That's what we're doing now. Okay, CDF means cumulative density function. Okay, and so the first one, 0 is going to be the same. And then try it out. So number of trials is still 4. Probability still 0.2. Now the X value I'm interested in here is 1. And if I know what I'm doing, it should add up both of these cumulatively. So this would be 0.8192. Make yourself a little visual here so that you can tell this box here is those two added together. So cumulative. So what should this one be? What plus what? Yeah, so these two boxes, let's just check. Yeah, nice job. So you know, this is the hole in my paper on my second page, so I have more. I'm so sorry to teach you things, important things.
Am I enjoying the tree diagram too much?
No, I just said I did a one, because then it goes up the tree.
He's grouchy. I'm also grouchy. Okay, all right, so we should know how to do this one already. This one we already did at the beginning of class. Probability x equals 8, and we're gonna do this both ways because you need practice on the other way too. So we're gonna do the stats way first because that's just become our favorite. Okay, now what makes this PDF instead of CDF? And it's one word in here. Exactly is the word I'm looking for. Exactly is telling you that it's PDF because it's equals 8. Okay, and so I have 50 trees, 0.168, exactly 8. NP. Oh no. X. Okay, now the other way. Fifty choose 8. Technically it's supposed to be combination 8, but fine. Okay, now that means we're gonna have 8 successes, so 0.168 successes, which means disease, but it's bad, but whatever, it's fine. We're just glossing over that. And then how many failures? 42 failures. Okay, and we don't even need to do the math. We already know it's going to be 0.1523 because of our previous work. Okay, do you know how to set those up? Okay, so now I just have to teach you one more thing, which is what to do with these types. 8 or less, more than 8, less than 8, greater than or equal to 8. They all have different PDF operations. So you guys know there's 4 different inequalities, right? The greater than crocodile, the greater than or equal to crocodile, the less than crocodile, and the less than or equal to crocodile. Okay, we need to take care of all 4 crocodiles here so we know exactly what to do in every scenario. Completely prepared. Okay. First one. X is less than or equal to 8. This is the less than or equal to crocodile. Your calculator's CDF function is the less than or equal to. That was this right here. These were less than or equal to, right? Okay. So all we have to do is binom CDF instead of binom PDF. Binom CDF is always less than or equal to because it's cumulative. It's adding them up as it goes. Everything less than or equal to it. Cumulative. Okay. So the keys, they're the same. 50, 0.168. Okay. Why is this one so much bigger than this one?
The 8, 7, 6, 5, 4, 3, 2.
Yes, so if you got stuck on a test or quiz, you could do binom PDF 0 plus binom PDF 1 plus binom PDF 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8, a giant string of decimales, and then get that answer, but you don't have to because you have to. Okay, are you ready? More than 8. Yes. Okay, this symbol indicates everything that this one is not. We call that the complement. And I don't even really need to, I can just do 100% minus this. Okay, almost there. So we have the less than or equal to crocodile, and we have its complement, the greater than crocodile. Okay, now we have the less than crocodile. And the less than crocodile is the same thing as the less than or equal to the one below it. Okay, what I mean by that is less than 8 is the same thing as everything up to 7. Let me say that again. Less than 8 is everything up to 7. Okay, so you're going to do, no, these are discrete because remember how the table looked? It was 0, 1, 2, 3. Exactly. You guys okay with me just writing down the stuff I calculated beforehand? Correct. Because it's this one's 8 or less, and this one's less than 8, so you don't include the 8. Oh, you're so smart. Okay, so the last one is the complement of this guy. It's the opposite of this one. Okay, so 8 or less is less than or equal to, that's the way your calculator speaks. More than is the complement of that, everything else. Less than 8 doesn't include the 8, so you stop it at 7. Because each tree is separate, it's not 7.9 trees. And then greater than or equal to 8 is the complement of that, everything else. Now you are prepared for every type of binomial inequality and equation. But I do want to show you my joke. And then I'm done. Here is my joke. Crapcats triangle. LOL cat, yeah, it does say LOL cat. So if you remember, you don't from math 3, but this one is the line equally, so this is 3 combination 0, combination 1, combination 2, combination 3. Remember we counted it over last week, it was fun, we did it. It was chapter 9, 8, 9, no, 8's polynomials. 9 is sine and cosine when you go.
I didn't think it.
Was it twin? That's not true.
I think one time I remember you. That is so high. We're looking at the elevation. You know, if there's-
I don't actually.
Like, oh.